Suppose an alien ambassador came to Earth. Would the alien be dangerous? Could we be killed? Let us send a robot in case the alien destroys anyone nearby. But let us think about how different could an alien be. The most alien-like animal on Earth is probably an octopus. How is an octopus different? An octopus has 8 arms. A human has only 2 arms and 2 legs. An octopus has 9 brains. A human has only 1. An octopus has 3 hearts. A human has only 1. An octopus has blue blood. A human has red blood. An octopus is mostly bendy muscle, while a human has a stiff skeleton. An octopus can escape through tiny openings, whereas a human would get stuck. A blue-ringed octopus has enough poison to kill many humans. Humans are not poisonous, but humans are safe, because humans live in the air and octopuses live in the water, except in Queensland. Let us pretend the alien ambassador is a bit like a really weird octopus. Our monster could be an image around a bottle, and we could see if we can make our robot swim towards it like a fish. Let us start up our Lego 51515 Scratch Kit Mindstorms. Click on that. We then click on Code, and we see in the corner that the red up here means that we haven't got a connection to our robot. We want to have a Bluetooth connection, so we click on that, and Lego kindly makes the suggestion. Thank you, Lego. We turn the robot on. We wait till a pattern appears, and then we press the Bluetooth connection. And we come down the bottom, click Connect, and you can see the blue flashing to show that we've got a connection. Good. Okay. If we want to control our robot, we use a computer language. The Lego opens up with Scratch, and we know that in Scratch, if we move something down, we can get motor A going in that direction for one rotation of the motor. But we know how to do that in Scratch. How do we do that in the more advanced language of Python? We go up here to the plus sign, left mouse click on that, and we see New Project. At the moment, grey area is around the word blocks which show we're using Scratch. If we change to Python, which we notice in beta, we click there. Beta means that this is a bit experimental and we may have some problems, but mostly, in our experience, it works pretty well at this stage. Okay, we click Create, and it changes to an entirely new system. Lots of words. No prompts for the motors that we have, no prompts for the controls that we have. So we're on our own to some extent, but Lego has provided a very nice help. Go to the right-hand side, click on that icon there, and we find Word Block Translator. Let's click on that, and we see some of the Scratch commands and their Python equivalents. Let's just try one of these. Here is a single motor on for seconds. That's motor A in that direction for 1 second. Now you see the Python commands are down here, and we type the first of these up here, motor equals motor A, and the second the command we type down below the hub speaker beep, and that's motor dot run underline 4 underline seconds open round bracket 1, 75, which means that it'll run for 1 second at 75% power. Now this won't work for two reasons. The first is that I've got a keyboard bounce and I had 2 O's in motor, but let's go down and click on the green play and see what happens. And does our robot move? No, it doesn't. So let's have a think about why this has happened. The motor command we copied from Lego's help system was motor equals motor A. Now you can see from the diagram of our robot that we don't have a motor connected to slot A. You can see the cable coming out, one from slot E and another from slot F. So we have motors connected to both slot E and slot F. None to A, B, C or D. And this time we only want to move the motor connected to slot E. So let's change the command to refer to slot E. So we'll change the motor A to motor E, and we'll try a test run and see what happens. Well, it worked. It went backwards. We want our robot to go forwards in a curving motion like a fish. Now, in a previous Scratch tutorial, 120-degree motor rotation with 30% power looked good. Can we do the same using Python? Now, if we go to the Python help, we find we're in the word block translator. We look down to see if there are any other blue ones, which are the motor commands, single and multiple motor commands, only for rotations though. We look down the rest, no dark blue motor commands. Right, but let's look down further at the headings. We go down further and we find single motors. Click on that, and there are a number of single motor commands, and one of them is run for degrees. Good, let's take a look at that. We find background information on that, which is useful if we want to be sure we know what we're doing. And here is our Python code. Now, first of all, up the top, before we can use this, we've got to have from Mindstorm's import motor. We've got to have that up the top of our Python program. And you can see up the top here, we got from Mindstorm's import a lot of other things, including motor. So we're right. Now, what can we use? Motor run for degrees 90. 90 degrees is 1/4 of a rotation. 360 degrees for one wheel rotation. So that'd be 1/4 of a real rotation. If we make it minus 90, that'd be 1/4 of a rotation in a reverse direction. But the one we want is this one, motor run for degrees 360. That's a full wheel rotation at 100% power. Okay, so let's change our command to that. So instead of seconds, we can delete seconds and we'll put degrees, D-E-G-R-E-E-S, and we want 120 actually, which we found was a nice fish-like movement when we did the Scratch version of this tutorial, and we want 30% power. So let us go down and see if we can get a run. We'll have a test run. Click play. Will it move? It does move. Good. It moves, but it moves backwards. Okay, so we'll need a minus 120 in there. Whoops. And we'll try that again. To make sure -120 works as the documentation says, click on that. And it moves forward. Good. That's just what we need. Now, if we're going to go forward in a fish-like motion, we need to use motor F as well. And we can put in a motor F. But immediately we strike a problem. We've got the same name for both motors, and this will confuse the program immensely. So we've got to distinguish between those. And the way we usually do that in Python is to use something like an underline, and I'll use an underline E for motor E, and an motor underline F for motor F. Now, this motor would have been motor E originally, and we'll copy that once. Only because the motor is put around the other way on our robot, we'll try that. So I haven't changed that to an uppercase. We want lowercase all the time. That's what's usual in Python, and particularly for beginners, it saves a lot of problems. There are a lot of errors come because of mixing upper and lower case in Python. There are only two things I don't like about Python as a language, and one is that it allows both upper and lower cases different. Okay, but let's forget about what I think and see if that works. Okay, so we'll do a test run. Oh yes, that's nice. Good. Right. Now to approach the alien, we can have three of these. Three fish-like movements from side to side, and we know from our previous one with Scratch that one more of those will make it face the alien. Cross my fingers. Right, okay. And whenever you put in extra code like this, you always test it straight away. My first tutor was a guy called John Boothroyd, who'd worked with Alan Turing, and he said all the time, little bit of code and then test, little bit of code and then test. It makes finding errors so much easier. Okay, well, let's hope there are no errors, and we'll see how this works out. Oh, looks nice. Oh yes, very good, just what we need. Now that was good code with no errors, but what would happen if we had bad code approaching the alien? Just a while ago we had two O's, a matter of fact 3 O's in motor because of keyboard bounce. Suppose we had keyboard bounce on a 0 like this, and I hadn't noticed it. Now what happens when we try and run that? Well, our robot's approaching the alien, and disaster! It's knocked the alien over. Oh, intergalactic warfare. Well, we hope the alien is not too upset and we end up like the shark. What does an alien do, an octopus do, when it sees danger nearby, like a bigger octopus? It runs, gets ready to run, and it runs. Well, perhaps we had better teach our robot how to retreat rapidly. Now, if we go to our Python help and we go down a little bit, we're under knowledge base at the moment. Here's a multiple motor command on for rotations, but there's not much help here. So let's go further down, and further down we'll find motor pairs. Let's take a look at that. Now there's a whole lot of information, and move tank is a command which probably would be good. Now we can go down, and first of all we know that we've got to have from Mindstorms import motor pair, and up here we see from Mindstorms import motor pair, so we're right, we can use that. Motor pair equals motor pair, that'll be E and F in our case, and motor pair 20 centimeters back in our case, and since we want to retreat, both left and right will be minus 100. Okay, so let's put those values in. You'll notice that we've motor pair E and F, and I put motor pair underline EF to remind myself that those are the two motors that we are pairing together in this tank command. And the extra command we add down the bottom is motor pair EF and then move tank 20 centimeters back at a speed of minus 100 for both motors. And one thing we want to make sure we do is remove that extra error. Now we've added extra code, so let's test it straight away. Our robot is moving up there, and then panic. Good work. We can get away fast. So let's stop our run there. We have completed our first challenge using Python. Now is the time to save our program so we can retrieve it again later. There are two suggestions when it comes to naming your code file. One, do not use numbers at the end of your file name. And two, choose a file name that tells you whether your code is Scratch or Python. Now, suggestion one, Lego Python rips any number off the right-hand end of your file name, adds 1 to that number, and then adds it back onto your file name preceded by a space. Weird. Thus, alien part 1 would be saved by Lego Python as alien part space 2.lms. Awkward. Use a word. Alien part 1 would be saved by Lego Python as alien part 1 space 1.lms. Better. Suggestion 2. If you're only using Scratch or only Python, you don't have to do this, but if you're using both, identify your file names differently. Perhaps you could use something like SC for Scratch code and PY for Python code. For example, Python code py alien part 1 would be saved as py alien part 1 space 1.lms. Scratch code could be saved as sc alien part 2 space 3, and that would be saved by Lego Scratch as sc alien part 2 space 4.lms. Now let's demonstrate that saving. We go to File and then Save As in the top left of the screen, and we've got to save it as some sort of name .lms. Now perhaps if we save it as py alien part 1, where the 1 is spelt out, .lms, and we can save it, we should be able to close down everything, and if we want to, we can then start everything up again to check that we can in fact get it. We go down to Mindstorms again. We click on Code. We can click on File, Open, and if we go down, we can find PY Alien Part 1 space LMS. We open that and we come immediately into our program. And again, we're in the Python program. We're back to where we were, so it's been saved satisfactorily. We will be adding more tutorials. Subscribe if you want to be notified when new tutorials for absolute beginners are added. Thank you for watching. Have fun with your marvellous LEGO Robot Inventor 51515 set.